I know you're saying, hey, would that so been done? Of course, the names of the stomachs from front to back are rumen, reticulum, omasum, and abomasum. That's the name of the stomachs. And you all have tried that one time. Rumen, reticulum. Rumen, reticulum. Rumen, reticulum. Anyway, you say some. Rumen, reticulum, omasum, abomasum. Just those two rumen reticulums. That's all I'm asking for. And sing like you know what to do. That's all I'm asking for. I am a cow, four stomachs if I eat all the green grass, out come the pie. Eat a bale of hay, I do not stop. Rumen, reticulum. Rumen, reticulum. Rumen, reticulum. Anyway, you say some. Rumen, reticulum. Omasum, abomasum. How the cows all gather on the lawn, dressed in leather up since dawn. To the store, they won't be gone. Don't wear silk, they got milk. Sing rumen, reticulum. Rumen, reticulum. Rumen, reticulum. Anyway, you say some. Rumen, reticulum. Mason, abomasum. Where has the emperor disappeared? No one in this here herd has heard. We done the only thing that we could do. We put Kelsey on the milk cart and Elmer on the blue. Drinking rumen, reticulum. Rumen, reticulum. Rumen, reticulum. Anyway, you say some. Reticulum. Omasum, abomasum. Now, if you want your hamburger cheese, go to South America and burn the forest down. Take some cows and grazing and it will pass. You get sweet milk, mudslides, and methane gas. Well, there's how such snippy comments make. Fatty pot roast, stupid steak. Hey, that's my heifer you're talking about. Another case of a open mouth saying rumen, reticulum. Rumen, reticulum. Rumen, reticulum. Anyway, you face on rumen, reticulum. Omasum, abomasum, singing rumen. So I think you get the general idea there. So you've got 4 stomachs, 4 chambers to the stomachs that we need to address on some level. So lecture 6, I believe there's a livestock club meeting tomorrow, Thursday, at the Dairy Complex. I could be wrong about that, but check your email, check your announcements. Labs this week. Everybody's got a way to get up there. Everybody knows they're going 2 o'clock or 4 o'clock, and then we have a makeup lab for last week at 6. So for those that were at the fair, we're going to start feed ID. We're going to present the forages. So you're going to have to learn what those are and what the characteristics of those are. We'll go down and show you where you guys are going to be responsible for doing dry matters. So you're going to be part of the management of the herd by providing that information on a weekly basis. So you have an opportunity to sign up using our Coster testing. We'll get the feeder to collect your feed samples. And then you guys will run them and then you'll post them in the lobby. So we'll have a sign up for that. And everybody there will probably continue our talk about feed preservation, focusing on hay, and we may have some fun with the carbon cycle. So four stomachs. Everybody's heard four stomachs, or a lot of you have heard four stomachs in a ruminant. That's not technically accurate. You have one true stomach and three pregastric chambers that process that feed and then present it to the true stomach. Oh, I gave you a better handout this time so we can see what's going on. If we're looking at the parts there, got the rumen, probably the omasum reticulum, abomasum on our sheep, our pregastric fermenter. We're going to focus today on the difference between the sheep and the pony. Our representative ruminant is the sheep. Our representative post-gastric fermenter is going to be the pony. And we're going to try to figure out over the next few lectures, how do we get from grass to milk? We got something that looks very different going in the front end than what comes out the udder on the back end. How does that happen? There's a lot of processing that needs to occur. How do we get that? We can think about it from a chemical perspective. We think about what do we put into a reaction, the reactants. We've got some sort of enzyme, and we got the products coming out. If we think about it broadly, we can make kind of the analogy of feed goes into the cow. Cow is our big bag of enzymes. And what comes out, among other things, is milk on the other. So how do we get there? We'll take a look at what goes in. So this is a typical cow up at the dairy, probably pen 4 or pen 1. Eats about 55 pounds of dry matter. So if you took the big pile of feed that they ate, dried it down, you'd have 55 pounds of dry matter there. We're about 50% dry matter on what we present to the cows. So that cow's eating 110 pounds a day. Half of it's water, half of it's dry matter. In that 55 pounds, we got about 10 pounds of protein, which we'll label crude, and we'll understand why in a couple weeks we call it crude protein. You've got 24 pounds of non-fiber carbohydrate. What's the other term for non-fiber carbohydrate we'll be using in this class? NFC, non-fiber carbohydrate. Neutral detergent fiber, we got about 17 pounds there. NDF, if we put everything in an ashing oven, we'd have about 2 pounds of minerals that go into that cow and about 2 pounds of fat. We don't count the other group there, vitamins. Vitamins, what they have is this little teeny tiny pile there, a fraction of a pound. That's what they eat per day. So we really don't, it gets lost in the noise of this measurement. So what comes out? We've got at least 90 pounds of milk coming out of that pen. In that milk, you're going to have 3.4 pounds of fat, 2.9 pounds of protein, about 0.6 pounds of ash, minerals, 4.3 pounds of lactose, and 78, 79 pounds of water are going to account for that 90 pounds of the milk. So mostly water, but you got some different things that you didn't see going into the cow in different proportions coming out of the cow, at least in the milk. Manure, if we put the urine and feces together, call that manure. We're looking at 150 to 200 pounds of wet material per cow per day. If we dry that down, we have about 24 pounds remaining. Dry matter that goes in the cow, goes all the way through and not changed. So if we think about 55 pounds of dry matter went in, 24 came out, what kind of digestibility are we dealing with here? Certainly absorption, things are being digested, absorbed. But if we take 24, put it over 55, we've got something that's indigestible. That means, what does that leave? 31 pounds is digested, disappears in the digestive tract. Over 55, about 50% digestible from front to back. So only about 50% of what goes in is used by the cow or extracted by the cow. There was some person a long time ago, it's, well, they're so inefficient about what they're doing there. What if we take their intestines and run it back through the rumen again? That's just not going to work. Somebody actually did it. And I'm like, what the hell are you thinking? But, you know, you need to get rid of that. But a cow starts with things that's very abundant, but not very digestible. So thinking about the grass, thinking about forages there. So what can a cow do with those carbohydrates that come in? Where have we said so far? What are the two fates of the carbohydrates that are digested? What's an example of a carbohydrate? Cellulose. We break that down into its constituent pieces. Those pieces of cellulose get absorbed as VFAs. Call those carbohydrates. They're in the bloodstream. What can happen to them? There you go. Build or burn, right? So most of it's going to go to burn to keep the animal running, but you're also going to use these things to build lactose, to build milk fat, to build milk protein. So we can use different things there. So if we're looking at a dairy cow, our ruminant, just like the sheep we had in the picture, we have a very complex stomach, very complex digestive system. And that's because a lot of processing has to occur inside that digestive tract to turn that into something useful, to free it up so the cow can extract it. So the advantage of all that extra work and the advantage of that complexity is with very simple inputs, we can get more complex outputs. We can generate required nutrients with not having to feed all the required nutrients. If you take the paper, I handed you out for handouts here, shredded it up, fed that to a cow, probably a little bit more than I passed out here, add a little urea to it, that cow can produce milk. Not a lot of milk, but you've got nothing resembling protein, lactose, milk fat in that, but the cow can convert that. Basically, paper is mostly cellulose, little nitrogen source. The cow can take care of everything. One of the things that is the competitive advantage of our dairy cows is the conversion of cellulose, NDF, into usable energy source and high quality protein. So just what I described there, feeding a cow newspaper, little urea, we can get a reasonably good protein delivered to the cow. So ruminants is a class, they are herbivores. They're going to take what's called an extent digestive strategy. Compare the extent versus passage. Extent in the sense that they take a feedstuff, they eat it, and they pound the snot out of it to get as much out of as they can out of each pound. And we're looking at 50 to 60% of what's consumed is utilized. They are characterized by rumination, the swallowing of the feed. It roams around in the rumen reticulum for a while. You get the scratch factor going. That stimulates rumination. That feed is brought up, regurgitated, chewed a set number of times. Has anybody heard that before? Every cow has their number. Every time they bring that bolus up, chew it, it's the same number every time. It's usually about 60 chews and then they swallow it. But some are 57, some are 62, some are 59, some are 60. It's a very programmed reflex. So ruminant's going to do 40 to 50,000 chews a day between eating and ruminating. So that 40 to 50,000 chews is going to take a significant part of the day. We probably have maybe a couple hundred if we're lucky. But typical dairy cow is going to spend 5 hours a day eating, chewing, inhaling that feed, chewing it, processing it. And then you're looking at 8 to 10 hours a day ruminating. The upper limit for a dairy cow seems to be 11. That's as much as I can put in ruminating a day. That's about the upper limit. So depends on how much NDF we put in the diet is how much we can process with all that chewing. So we can reach a top level, and we're probably going to try to do that during sale week, push those heifers to their limit. If we look at ruminants as a suborder of animals, they have been very successful. They are in every single climate on the planet. Don't think they're on Australia, but you've got other herbivores that have taken over there. But you've got Arctic animals all the way down to the tropics. The astonishing thing to me about the ones up in the Arctic, the reindeer, the muskox, how short they are. I thought muskox were this tall. They're only about this tall. So I went to the Large Animal Arctic Research Center in Fairbanks, Alaska, and that was a revelation. So if you're a herbivore, you're eating something that doesn't really match what you are, you're going to go about it in different ways of thinking about it. So broadly, you're going to divide herbivores into ruminants and not ruminants. And then you're going to look at what's their strategy for getting nutrition. Do they select very carefully what they eat? Or do they just try to get in as much as they can and will process in bulk? We'll make it up on a wholesale basis. So you have concentrate selectors, the ones that tend to go around and pick the tips of the grass. We'll pick the berries off the trees, all the best stuff. Usually they have more articulate lips. You start to think of a sheep or better. The intermediate feeders, the ability to move things around to select a single leaflet from an area. They're going to, by nature, pick a more highly digestible food. So maybe they don't have to eat as much. our cattle down here deal in volume. How does a cow work pastures? Anybody watch that? Tongue comes out, wraps around the grass, rip, right? So we're just sweeping it in. We got that tongue and we're sweeping it in, dealing in volume here. We're not selecting things, although there's a certain amount of selection. They're going to work the tops, not the bottoms. Horses are going to be over here as our non-ruminant. They're eating like a horse. So we're trying to get volume in both of these operations. So we've got two different strategies digestively. The ruminant on the right, the post-gastric fermenter on the left. So when we're comparing those two, the pictures where the pony is sheep, or we can think of a cow, we have the pony has a passage strategy. The ruminant has the extent strategy. And we'll explain what those are in a minute. You're looking with the pony is going to have fermentation after most of the digestive tract. Their digestive tract bigger, but it's about the same as yours and mine, all the way up to the large intestine. Same as a pig, all the way up to a large intestine. The sheep is going to ferment before. So looking at the two different, that's right, two different approaches. The passage, I try to process as much feed as I can through my digestive tract. I pull out as much nutrition, digest as much feed as I can quickly and move it on through. So I'm going to put a whole lot more through the system, taking a little bit from each, but I'm not going to spend a lot of time with it. You're looking at less than 24 hours from nose to anus. The panda is the extreme in this strategy. Does anybody know what pandas live on? Bamboo. They have pretty much the same digestive tract as you and I, but they live on bamboo. They have about a 2% digestibility of the feed they consume. So sort of what goes in looks very similar to what comes out. But because they put a large volume through, pulling out 2% out of every pound, they can generate enough to live. So it's sort of like those cash grabs. You catch as much as you can, as fast as you can, and then you move on. Do it again, as fast as you can, as opposed to trying to get everything. We get the good stuff, the easy stuff, move it out. And then all the stuff that's not really good ends up in the post fermentation, the cecum, the colon, the large intestines, and some stuff will be fermented there that's not really good for the horse or not really digestible for the horse, and she'll extract some energy from that. Then it passes out. So you're looking at maximum nutrients per minute. How fast can I get stuff through? How much can I extract per minute? The ruminant does an extent digestion strategy. I'm going to process this feed. I'm going to jump up and down on it. I'm going to chew, 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 and try to extract out as much out of each pound as I can. So you're spending more time processing. The time from one end of the digestive tract to the other for a cow is 2 days. More than twice as long as what you'd find for a horse. But it's in there, it's being processed. Usually the first 24 hours is in the rumen. The rest of the digestive tract has the rest. So we're trying to maximize nutrients extracted from each pound. You're not going to be perfect. You're not going to be 100%, but you're spending more time fermenting things so you can extract more stuff with the microbes helping you out. You're going to have a slower passage through the body. So what does that do to the body shape? Big guts, right? You've got to hold 2 days worth of feed in your body cavity as opposed to one. Or if you're a carnivore, you do a half day's work by the time it goes through. So if we think about the energy extracted, and we'll talk about this term TDN, total digestible nutrients. How many pounds of digested material do these animals absorb? And we can determine that by the equation of how many pounds of intake times by the digestibility of that determines what your TDN pounds are. We don't use TDN so much other than to explain this, but most nutritionists will never utter the words TDN when they're feeding cows. But we need to understand that here. So if you're working in the passage strategy, which side of the equation or which part of the equation are you working? Intake or digestibility? If I want to increase this and I'm a horse, I have to increase my intake, pushing more through. If I'm an extent strategy, I'm going to increase the digestibility. So on the same intake, I will get more pounds of digested nutrients. So ways to get at the same thing, we can either increase the intake or increase the digestibility. Intake is a passage strategy. Digestibility is an extent strategy. Everybody see that? So our ruminants are focusing on that. Extent, pony on the passage. Both are using fermentation. It's pretty much chemically the same. It's just in a different location. So with the cow or the sheep, the microbes get the first crack at everything. That has some advantages and disadvantages. One advantage is it detoxes things. Horses get sick, sort of look at them funny, right? You can't feed a horse off silage. You got to feed real good silage. You can feed a cow off silage and get away with it for a little while because of the detox effects in the front. The downside of having that fermentation in the front is all the real good stuff gets destroyed by the microbes first. Has anybody heard of Japanese Kobe beef? So what do they do to make that beef wonderful besides giving the cows massages? What else do they do? Does anybody know? Anybody heard they continue to bottle feed those animals all the way up through adulthood? Does anybody here know what the esophageal groove reflex is? So the esophageal groove, and we'll get to that in a minute, is a tube that forms. It's a reflex, a fold of skin that takes nutrients past the rumen directly to the true stomach. What they do with this beef is they continue to keep that reflex going. So if they feed them all kinds of high-end protein and vitamins and all that stuff, it'll bypass the rumen. So we're taking the bugs out of the equation for whatever's fed in the bottle. So they're not going to destroy all that good stuff that we're using to allow those ruminants to become that high-end beef. So whatever, but normally we don't do that. With our adult cows, whatever comes out of the rumen is either digested and absorbed, or it passes through the body. We're doing our fermentation up front. We hope the fermentation unlocks the NDF and makes it available to the animal. So I think you have this diagram somewhere. So we've got our parts, thinking about our cow. So this is looking at from the left side, you're going to have the omasum, abomasum, reticulum is going to be down low between the legs, and the rumen is going to dominate the left side of that animal. So what's wrong with this picture? The focus of this picture is to show you where the stomach is. So you got the lungs in front, you got the diagram shaping that. The small intestine, large intestine, that drawing does not represent them at all. But we're focusing on just one thing there. So remembering, usually if you have a drawing, there's an error in it somewhere. You have to learn what the focus is and why that thing exists. So just like the song we heard up front, things tend to go rumen, reticulum, omasum, abomasum. So we've got the 4 stomachs, the 4 compartments, and we'll go through them one at a time to try to explain what they do and how they do it. So this is probably more representative of how it kind of sits than the last one, although I think the abomasum is probably a little bit farther back, given my experience. So we can look at things from 2 directions. So if we're looking at cranial, means toward the head. So you have your stomach here, and then you flipped it over. So the cranial side on this view is now pointing that way. Caudal means tail. So you have, this is looking at the right side of the cow, the left side of the cow. And what we need to remember here is that you have a very large forestomach, very large stomach that is, with all those grooves that are there, very well supplied with blood. It has a tremendous amount of nerves going on there to sense things and to control things that flow in those groove spots. Those are where the nerves, the big nerves come, and then they spread out as they go through. So thinking about the rumen here, we're looking at it from the left side of the cow. We've cut it in half. So we've got the rumen here. And then the reticulum is up front. This is the esophagus coming in. So we'll get an opportunity in the next couple weeks. I need to get you rolling on your feed IDs. Once we get that done, we'll go and do a rumen dive and make everybody very smelly. So you're going to have a cut into the cow that comes in from the left side. So that's where the port is to access that rumen. You'll be able to reach in with your arm and feel all these different parts. So if we go back first, we're going to have the dorsal blind sac. And the oddity of this particular cow's anatomy is that you will drop her hole sits a little bit farther back. So you're going to run into this shelf of tissue immediately. It's a little bit farther back in the dorsal rumen. You go around that shelf and you're going to get into the ventral blind sac. So you're going to have 2 pockets at rumen. As you work, we'll empty out the rumen. You'll be able to feel as you move forward with your right arm. You'll be able to feel a first wall of tissue as you go forward. That's called the cranial pillar. We go over top of that, we're still in the rumen. The next one we're going to run into is what separates the reticulum from the rumen. So you're going to go up, over, and you're going to run into another one here. You go up and over, and you're going to be in the reticulum. You have the esophagus coming down, and the entrance with the esophagus up here. And then we have at the other end of this kind of groove there, you have what's called the root, the reticulo-omasal orifice. So the root. The entrance to the esophagus and the root have between them the esophageal groove. And what you have there is some folds of skin. If you look out on the screen there, those folds come up and form a pipe that leads from the esophagus to the root. So for a calf, we don't want to ferment the milk. That's a good source of protein. We don't want to destroy it by the microbes. We use the calf uses that to shunt the milk directly to the omasum or the abomasum. And if you're doing Colby beef, you keep using that bottle all the way up into adulthood, you can maintain that reflex, maintain that tube. So if we're looking at the 4 compartments of the stomach, what are we dealing with? Each of the compartments of the stomach has a unique feature that increases the surface area for absorption. Papillae are what increases the area, increases the opportunity for absorption in the rumen. Little fingers that come up from the side. You're going to see what looks like a bad 1970s shag carpet in the rumen. So this is 2 different pictures. Little fingers coming out, little tongues coming out. As our cows do more and more fermentation, those papillae lengthen out and increase the absorptive surface area to remove those VFAs, that fermentation product, as fast as it can. We don't have a lot of fermentation, they tend to shorten up. So that's one of the reasons for a close-up diet, is we want to lengthen those papillae out again to get ready for lactation. You're looking at 30, 40, even 50 gallons from a mid-sized Holstein. So the cow we're working with, she's just past peak. We're going to fill a pretty good sized garbage can with her stomach contents. So I think that's a 35-gallon garbage can. We'll have that heaping full, I'm guessing, depending on when we have lab and when she ate last, when we feed them. So the key function of the rumen is the fermentation. We'll talk more about that next lecture. And the job of fermentation is to turn carbohydrates into VFAs. So CHO, carbohydrate, is the definition or the abbreviation I use. VFA, come back to this, volatile fatty acid or acids, depending on what we're context of the sentence. So it's easy to do with the starch. The bugs ferment that very quickly. With the cellulose, it's going to take a little bit more. We have to unlock that cellulose, let that cellulose go. We also have in the rumen a lot of absorption. So The absorption, a lot of the VFAs produced in that fermentation need to be removed. If we don't remove it, we get this big pH drop and bad things happen. So we need to continuously absorb and remove those VFAs, those acids, from the fermentation. Paired up with the absorption of those is electrolytes. Every VFA goes in, there's a matching electrolyte that goes with it. So the electrolytes, does everybody remember what they are from chemistry? What's Na? Sodium. Cl is chloride. K is what? Potassium. So the things you're going to find in Gatorade. So your electrolytes are going there. Reticulum has a honeycomb pattern for increasing absorption. You'll also see it on the menu in some restaurants called tripe. I can't bring myself to do it. So it smells too much like the inside of a rumen, and I just don't want to go there. So you're looking at something like this. It's not a perfect hexagon like the bees do, but you've got the ridges, you've got the little fingers on the ridges, you got lots of little sub-ridges. All are increasing the absorptive surface area, and with those little ridges and figures responding to the scratch factor that stimulates rumination. If she's kind of learned the trick, but if you stick your arm in that cow, reach into the reticulum and scratch the wall a little bit, she will start chewing. She's got nothing there because we didn't allow her to bring up a cud, but she will start grinding her teeth. That's called pseudo-rumination. So I call the reticulum the director. The reticulum decides what stays in the reticulum and rumen, since they're sort of connected together, and what leaves. What goes up to the mouth to be rechewed, what goes down to the lower tract, what goes back into the rumen for more time. So for a dairy cow, you're looking at something the size of a football. And that can go big and small depending on what you're doing. It has the entrance and the exit. The esophagus coming in, the roux going out. So you have the end of the esophagus, the esophageal groove, and the roux going out. So this is a baby calf who was born with water brain, I guess it was called. So they dissected as part of vet skills class to learn where everything was. I kind of took the stomach over the side and took some pictures. So you have the very immature reticulum. You can see the honeycomb pattern there. I've got a forceps coming through, going in the esophagus down to the omasum, and you can see that that metal piece is sitting in a groove. So we're looking at a diagram there. We want to get that good milk. We don't want to ferment it. That lowers the quality. We want to get it from the esophagus to the abomasum, the true stomach. So that groove there, if we can see those folds coming up to form that tube, that forceps will be inside that. So you kind of pull on it. As it contracts, it tends to form that tube. So the reticulum is central to most of the functions we think about as a ruminant. You've got rumination, the cud is formed there, goes up the esophagus, comes back down. Eructation, does anybody know what that is? The removal of gas from the rumen. And wherever we've got fermentation, we've got the production of gas. Has anybody been to a winery or a distillery or anything like that and seen those big fermentation vats just bubbling away? That gas has to be removed, or what happens? Does anybody want to guess? Bloat, right? We got to get rid of that gas, or they're going to basically swell up. The gas, the microbes don't care, will push against the lungs, push against the heart, eventually suffocate the animal. Passage, the reticulum decides what leaves and what goes. Stays. So particles have to be small enough to leave. So you're looking at something about that length, have to be chewed down, processed. Then they can leave. Everything else is strained. Along with the omasum, it strains, keeps the large particles back. Any questions on the rumen and the reticulum? Going too fast, too slow? Doing all right? Everybody's catching it, time to write, all that stuff? Okay, so I got a quiz for you to finish up the day. We'll talk about the omasum next Monday. So put your materials away and I'll pass out the quiz. When you're done with the quiz, you are free to go.